Let's go into the unknown. Antichthon. Around 450 years before the Common Era, a Greek philosopher named Philolaus of Croton proposed something that no astronomer before him had dared to commit to writing. Not that Earth was round, not that the planets moved in patterns, but that directly opposite us, permanently hidden behind the sun, was another world. He called it Antichthon, the counter-Earth. And he built it into a mathematical model so precise that serious thinkers argued about it for centuries. Before Philolaus, the Pythagorean tradition had already broken from the comfortable assumption that Earth sat motionless at the center of everything. But Philolaus went further. He proposed that both Earth and the counter-Earth orbited a central cosmic fire, the Hestia, the hearth of the universe. This was not poetry. This was a geometric framework, a working cosmological engine, and it required exactly 10 celestial bodies, because 10 was the perfect number. The Pythagorean ideal, the number that completed the cosmos. The model included the sun, the moon, Earth, the 5 known planets, the fixed stars, and the cosmic fire at the center. 9 bodies. Philolaus needed a 10th, so he placed a world behind the sun, in the one position that could never be directly observed, orbiting in perfect counterposition to Earth. Aristotle, writing in On the Heavens around 350 years before the Common Era, critiqued this directly, arguing the counter-Earth was invented to make the numbers work. But Aristotle also could not disprove it. And the geometry, as it turns out, was not entirely wrong. Modern orbital mechanics has confirmed that stable co-orbital positions, called Lagrange points, genuinely exist. The Trojan asteroid families at Jupiter's 4th and 5th Lagrange points prove that co-orbital bodies are not theoretical. They are there. The most unsettling detail is the motive. Philolaus did not need a 10th body for religious reasons. He needed it because the mathematics demanded it. He followed the numbers to a world he could not see. That is not mythology. That is the scientific method, applied 2,000 years before anyone gave it that name. When a philosopher finds a hidden world by following an equation, and modern orbital mechanics confirms the equation was structurally sound, the question stops being about Philolaus. It becomes about what else the numbers are pointing to that we are not yet ready to follow. Hyperborea. The Greek historian Herodotus was not a poet. He traveled. He interviewed witnesses. He distinguished carefully between things he had seen himself, things he had been reliably told, and things he considered legend. Most scholars remember him as the father of history. Fewer remember that in his writings he treated the Hyperboreans not as myth, but as a reportable people, a civilization beyond the north wind, real enough to receive sacred offerings through a chain of intermediary cultures stretching from Greece to the Arctic. The name itself is a geographic instruction, not a metaphor. Hyper means beyond. Boreas is the north wind. Classical sources do not describe Hyperborea as a paradise in the vague spiritual sense. They describe it with climatic specificity, a land where the sun does not fully set, where winters are mild and the light is constant, where the inhabitants live to extraordinary age without disease. Pindar, writing around 500 years before the Common Era, placed it as a real destination. Hecataeus of Abdera wrote an entire treatise on the Hyperboreans around 300 years before the Common Era. That treatise is now lost. What survives is detailed enough to locate. The description of perpetual or near-perpetual sunlight corresponds to subarctic or Arctic latitudes. The references to specific migratory routes for sacred offerings, passing through Scythia, the Adriatic coast, and eventually Delos, trace a real geographic corridor northward into regions that ancient Greeks had genuine, if limited, contact with. And in 1595, the Flemish cartographer Gerardus Mercator published his famous polar projection map and placed a large northern continent at the pole, divided into 4 landmasses separated by rivers. He did not invent this. He compiled it from sources he considered geographically reliable. That northern continent does not exist today, but geologically, the Arctic was not always as we find it now. Ice cores and sediment records confirm that the polar regions have been temperate within geological memory. Herodotus did not mark Hyperborea as myth. He marked it as a place people sent offerings to and sometimes visited. He was not known for inventing destinations. A civilization described with geographic coordinates, climatic accuracy, and navigational placement by the father of history is not mythology. It is a lost address. Vulcan. In 1859, a French amateur astronomer named Edmond Lescarbault wrote a letter to the most celebrated scientist in Europe, claiming he had watched an unknown planet cross the face of the sun. Urbain. Leverrier, the man who had predicted the existence of Neptune using mathematics alone before any telescope confirmed it, read the letter, boarded a train, and rode directly to Lescarbault's village in Orgères-en-Beauce to interrogate him in person. What Leverrier found there convinced him. He presented the sighting to the French Academy of Sciences and named the new world Vulcan. Leverrier's interest was not casual. For years he had been troubled by a specific anomaly in Mercury's orbit. The planet's perihelion, its closest point to the Sun, precessed at a rate that Newtonian mechanics could not fully explain. The discrepancy was 43 arcseconds per century, a number small enough to ignore and large enough to be maddening. Leverrier had solved this kind of problem before. When Uranus drifted from its predicted path, he calculated the position of an unseen body exerting gravitational pull, and when astronomers pointed their telescopes at the coordinates he gave them, Neptune was there. He applied the same logic to Mercury. There had to be another planet, closer to the Sun, massive enough to account for the drift. After Lescarbault's report, multiple astronomers recorded Vulcan transits throughout the 1860s and 70s. The search intensified during solar eclipses in 1869, 1878, and 1900. Each time, the evidence dissolved under scrutiny. Then in 1915, Einstein's general theory of relativity solved Mercury's orbital anomaly without requiring a hidden planet at all. Vulcan was declared a ghost, but something worth noting was quietly buried alongside it. Einstein's solution did not explain why Newtonian mechanics had worked everywhere else in the solar system for centuries, and failed only in this one specific orbital region near the Sun. The solution removed Vulcan. It did not explain why that region of space required an entirely new physics to describe. Leverrier found Neptune with mathematics alone. When he turned the same mathematics toward an anomaly inside Mercury's orbit, he was not guessing. He was doing the same calculation that had worked before. Whether he found a ghost or a real body that has since disappeared, the math was pointing at something. It still does not fully explain why it needed to. Planet X. In 1906, Percival Lowell, the astronomer who had spent a considerable personal fortune trying to prove that Mars was inhabited, turned his obsession to the outer solar system and began calculating the existence of a massive hidden planet he called Planet X, not as a dramatic name, as a mathematical variable, the unknown. He was looking for a body large enough to explain why Uranus and Neptune drifted slightly from their predicted orbits, pulled by something the known solar system could not account for. Lowell died in 1916 without finding it. His observatory in Flagstaff, Arizona, continued the search. In 1930, a young Kansas farmer turned astronomer named Clyde Tombaugh, working a systematic photographic survey at the Lowell Observatory, discovered a faint moving object at the calculated coordinates. The announcement made headlines worldwide. Planet X was found. It was named Pluto. The celebration did not last long. When astronomers calculated Pluto's mass, it was nowhere near large enough to explain the orbital perturbations Lowell had identified. Pluto was not Planet X. It was something else. The search resumed. In 2016, Caltech astronomers Konstantin Batygin and Michael Brown published a paper in the Astronomical Journal presenting compelling evidence for a trans-Neptunian object with a mass 5 to 10 times that of Earth, orbiting the Sun on a highly elliptical path with a period of 10,000 to 20,000 years. They had found it the same way Leverrier had found Neptune. Not by seeing it. By calculating the gravitational fingerprint it leaves on other bodies. 6 trans-Neptunian objects had orbital clusterings so statistically anomalous that the probability of those patterns forming by chance was less than 1% by conservative estimates. Something was organizing the outer edge of the solar system. That object has still not been directly observed. No telescope has confirmed it, but the math has not gone away. Lowell started this search in 1906. Brown, the same astronomer who found Eris and triggered Pluto's reclassification, is still running it today. A century of searching, 2 independent mathematical predictions pointing at the same dark region of sky, and the unknown remains precisely that. The variable is still unsolved. Maldek. Between Mars and Jupiter sits a belt of rocky debris. Millions of fragments ranging from fine dust to objects hundreds of kilometers wide, circling the Sun in a band so consistent, so geometrically ordered, that it looks less like random debris and more like something that used to be somewhere else. In 1778, German astronomer Johann Elert Bode formalized a mathematical sequence, now called the Titius-Bode law, which predicted a planet should exist in that exact region. When Ceres was discovered there in 1801, astronomers celebrated. They believed they had found it. Then they found another object, and another, and another, until it became clear that the belt was not one world, but thousands of pieces, and the celebration turned into a question that has never been fully answered. The name Maldek comes from theosophical tradition, not from peer-reviewed science, and that distinction matters. But the underlying astronomical question, whether the asteroid belt is the remains of a world that was destroyed rather than a world that never formed, is a legitimate and ongoing scientific debate. The Standard Model holds that Jupiter's enormous gravity prevented planetesimals in the region from accreting into a single body, a process described in the Grand Tack hypothesis published in 2011. Under this model, there was never a planet. There was only debris Jupiter would not allow to organize. The rocks disagree. Meteorite analysis has confirmed that some asteroids in the belt originated from differentiated bodies, objects that had already developed iron cores, silicate mantles, and crusts. Differentiation requires a planetary scale body. You do not develop an iron core without gravity sufficient to separate heavy and light materials over geological time. Some of the material in that belt came from something that had already become a world. The question is not whether a large body formed there. The geochemistry says it did. The question is, what happened to it? The Grand Tack hypothesis explains the belt's low mass. It does not explain the differentiated fragments. Jupiter's migration accounts for why the region is so depleted. It does not account for why the remaining material carries the signature of a full planetary interior. The math clears Jupiter. The rocks tell a different story. If those asteroids came from a world that had already built an iron core, a mantle, and a crust, then whatever is orbiting the Sun in that belt is not primordial debris. It is rubble. And rubble implies something that was whole. Tiamat, the oldest creation story that survives in written form, does not begin with light emerging from darkness, or a god breathing life into dust. It begins with collision. The Babylonian text, known as the Enuma Elish, composed around 1800 years before the Common Era, but believed to preserve Sumerian traditions far older, opens with 2 vast primordial bodies. Apsu, fresh water, Tiamat, salt water, and it describes in meticulous narrative detail Tiamat being split in 2 by the god Marduk. One half becomes the sky, the other becomes the earth. For 3,000 years, this was classified as mythology. Then planetary scientists started modeling the early solar system. The giant impact hypothesis is not fringe science. It is the current mainstream model for the formation of the Earth-Moon system, and it describes, in the language of orbital mechanics, a Mars-sized body called Theia colliding catastrophically with proto-Earth approximately 4.5 billion years ago. The collision destroyed both bodies in the impact zone. Debris coalesced into the Moon. Earth reformed from what remained. The name Theia was chosen deliberately. In Greek mythology, Theia was the Titan mother of Selene, goddess of the moon. Even the scientists naming the hypothesis reached for mythological language. In 2016, a study published in Nature found that lunar rocks and Earth rocks share nearly identical isotopic compositions, oxygen ratios, titanium signatures, tungsten profiles, all pointing to a shared origin in a single catastrophic mixing event. The evidence for Theia's impact has never been stronger. The detail in the Enuma Elish that resists easy dismissal is the saltwater. Tiamat is not a generic primordial force. She is specifically described as a body of salt water. Planetary scientists have confirmed that Proto-Earth had extensive surface water in its earliest period. The Sumerians did not have orbital dynamics or isotope spectroscopy, but they described a wet world being destroyed in a collision with a precision that requires more than imagination to explain. The mainstream model says Earth was born from a collision. The oldest written creation myth says the same thing. One of those arrived at the answer using particle accelerators and lunar samples. The other arrived there first. Phaeton. The story is this. A young man borrows his father's chariot of the sun, loses control of the horses, plunges too close to the earth, scorches the land, and is struck down by Zeus with a thunderbolt before the world can be incinerated. The Greeks called him Phaeton. Most historians have filed this under cautionary tales about hubris and ambition, but Plato did not read it that way. In Timaeus, Plato recorded that Egyptian priests had told the Athenian statesman Solon that the myth of Phaeton described a real astronomical event, a deviation in the bodies moving through the sky around the earth, leading to catastrophic destruction by fire. Plato was not a poet. He was drawing a direct line between a story and the sky. The Phaeton hypothesis in modern planetary science is the proposal that the asteroid belt represents the remains of a former planet, destroyed in the early solar system, most likely through collision or gravitational disruption by Jupiter. German astronomer Heinrich Wilhelm Matthias Olbers proposed exactly this in 1802, the year after Ceres was discovered. The hypothesis has never been definitively confirmed or definitively eliminated. The physical evidence that gives it traction is the structure of the belt itself. Within the asteroid belt are zones of near total emptiness, called Kirkwood gaps, cleared by Jupiter's orbital resonance over millions of years. This pattern is precisely what you would expect to see if a planet had been disrupted, and its debris was slowly sorted and evacuated by Jupiter's gravitational influence. The belt does not look like a place where a planet failed to form. It looks like a place where one used to be, and where Jupiter has spent millions of years rearranging the wreckage. The Tagish Lake meteorite, which fell in Canada in 2000, and the Allende meteorite, which struck Mexico in 1969, both preserve pre-solar material indicating that some asteroid belt objects predate the formation of the planets. The belt contains layers of time stacked on top of each other, and not all of them begin at the same point. Plato said Egyptian priests described it as a real event. The Kirkwood gaps look exactly like the aftermath of one. At what point does a myth become a memory? Nibiru. Around 1200 years before the Common Era, Babylonian astronomers completed a star catalog of extraordinary precision. The text, known as the Mul.Apin tablets, now held in the British Museum, tracked the positions, risings, settings, and periods of stars and planets with systematic rigor. These were not astrologers in the popular sense. They were empirical observers who accurately predicted lunar eclipses, calculated the synodic period of Venus to within seconds, and built a framework of celestial mechanics that Greek astronomy would later inherit and claim. Within this catalog, among the known planets and fixed stars, there is a body that does not behave like the others. It crosses. It arrives at irregular intervals. It does not follow the orderly path of the known planets. The Babylonians called it Nibiru, the planet of the crossing. The scholarly debate over what Nibiru refers to has never fully closed. Mainstream Babylonian scholars generally interpret it as a name for Jupiter, or a specific point in Jupiter's orbit, but this interpretation rests on one ambiguous passage in the Mulapin text, a phrase whose cuneiform does not resolve cleanly into either reading. Both translations are defensible. That ambiguity has been doing a significant amount of quiet work in the official narrative for a very long time, given what the alternative reading implies. Several Babylonian tablets describe Nibiru causing disruptions to the positions of other planets during its crossing. The language used is gravitational in effect, if not in vocabulary. A body that perturbs the positions of other planets, appears on an irregular schedule, and crosses the sky on a path distinct from the known planetary band is not a description of Jupiter. Jupiter is predictable. Jupiter does not arrive. Jupiter is always there. The Caltech calculations for Planet 9 describe an object at 200 to 1200 astronomical units from the Sun, on a highly elliptical orbit with a period of 10,000 to 20,000 years. A body like that would appear at irregular intervals, cross the inner solar system's observable field, and produce measurable gravitational perturbations on other planets. The Babylonians tracked eclipses to the second. When they described something that crossed and disturbed the planetary order, they were making an observation. Whether we are prepared to take their word for it is a different question entirely. Chronos. There is a hypothesis that sits at the intersection of plasma physics, ancient mythology, and planetary formation theory, and it almost never gets discussed in mainstream scientific circles, despite containing at least one peer-reviewed component that no one has satisfactorily refuted. It begins with Saturn. Specifically, it begins with the strange global consensus, across cultures that had no known contact with one another, that Saturn was once the supreme celestial deity, the original sun, the ruler of a golden age of warmth and light that preceded the current solar order. In Roman tradition, Saturn's reign was the age before ages. In Vedic cosmology, Shani holds a position of supreme temporal authority. In Mesopotamian astronomy, Saturn carries the title of the Son of Night. The consistency across isolated traditions is the kind of pattern that the reference scripts in this channel were built to examine. The scientific framework that attempts to explain this consistency was developed by comparative mythologist David Talbot and plasma physicist Wallace Thornhill, and it proposes that Saturn was once a brown dwarf star, a body with insufficient mass for sustained hydrogen fusion, but sufficient to emit heat and light, with Earth in close polar alignment within its plasma sheath. The solar system, in this model, was later captured by our current sun, disrupting the configuration. Brown dwarfs are not exotic or theoretical. The Spitzer Space Telescope has confirmed they are among the most common objects in the galaxy. The peer-reviewed component is the work of physicist Anthony Peratt, published in IEEE Transactions on Plasma Science in 2003. Peratt ran high-energy plasma discharge experiments and documented the shapes produced when plasma columns interact at different energy levels. He then compared those shapes to ancient rock art from Peru, Egypt, Scandinavia, and the American Southwest. The correspondence was not approximate. The shapes matched with a precision that Peratt considered statistically significant, enough to publish in a peer-reviewed engineering journal. If Earth once orbited within a different stellar configuration, then every ancient sky description that does not match our current solar arrangement is not mythology. It is eyewitness testimony from the last time the sky looked different. And the rock art of three unconnected ancient civilizations drew the same plasma discharge shape, a shape that can only be reproduced in a laboratory under conditions consistent with a brown dwarf discharge event. What exactly were our ancestors watching? The nameless body. There is a pattern in the ancient astronomical record that does not resolve cleanly into coincidence. The Sumerian star tablets, the Egyptian Dendera zodiac, the Vedic astronomical texts of ancient India, the Dresden Codex of the Maya, all of these traditions, built by cultures with no documented contact, came to the same count of the solar order, and that count was always one higher than what we currently observe. Not random, not inconsistent. Always one more body. Always massive, always distant, always described as arriving on a long return cycle, and always associated in the surrounding text with catastrophic change when it appears. The Dendera zodiac, carved into the ceiling of the Temple of Hathor in Egypt, and now housed in the Louvre since 1821, contains planetary positions calculated by astronomer Juan Antonio Belmonte to correspond to the sky of approximately 50 years before the Common Era. But it also contains bodies whose positions do not correspond to any planet in the current solar catalog. The Dresden Codex, one of only 4 surviving Mayan books, contains a Venus table accurate to within 14 seconds over a 104-year cycle. That level of precision is staggering. The same codex contains a table for a second body with a cycle of approximately 117 days that does not match any known planet. The Dogon people of Mali are the detail that no explanation has cleanly resolved. French anthropologists Marcel Griol and Germain Dieterlen documented Dogon astronomical knowledge in 1931. The Dogon described Sirius as a binary system. They described its companion as a dense, invisible star with a 50-year orbital period. They described it as the heaviest star in their cosmological framework. Sirius B, a white dwarf and one of the densest known stellar objects, was not photographed until 1970. The Dogon's orbital period figure for Sirius B was accurate. Their description of its density was accurate. They said this knowledge was given to them by beings who came from that star system. Anthropologist Walter Van Beek, revisiting the Dogon in 1991, found this knowledge less widespread than Griol had reported, and the debate has not closed since. But the broader pattern holds regardless of any single data point. 5 independent civilizations, separated by oceans and millennia, each tracking the sky with precision sufficient to calculate planetary periods to within seconds, all described the same extra body. They were not confused. They were recording something they had observed. Whatever they were looking at is not in any catalog we have published. Not yet. Look at what this list actually describes. Not 10 separate mysteries, but one recurring question asked 10 different ways. Ancient cultures across the planet, working independently, without telescopes, without orbital mechanics, without particle accelerators, kept arriving at the same conclusion. The solar system contains more than we are currently counting. They found it through geometry, through mythology, through plasma observation, through naked eye astronomy precise enough to calculate eclipse cycles to the second. Every single tradition on this list points to something in the sky that the official count leaves out. Modern science, using peer-reviewed mathematics and gravitational modeling, has now independently confirmed that something at the edge of the solar system is organizing the orbits of trans-Neptunian objects in ways that cannot be explained by the known planetary roster. The ancients did not know what it was. We still do not know what it is. But across 12,000 years of human skywatching, no civilization that looked carefully enough stopped at the number we currently use. If this video changed how you see the ancient record, leave a comment telling us which item you think is the smoking gun, and make the case for why. The floor is yours. The sky above us is the same sky they watched. They saw something we are still looking for. Subscribe, because the search is not over.